Who is Steve Jobs?
In this video, we're going to learn about image detection in visionOS, and we'll do that by bringing this book to life with videos. If I flip through a different page, you can see the image is out of view, and when I go back, it's visible again. Great, so let's open up a new Xcode project. Click visionOS here, select app, and then click next, and then name it whatever you want. And then make sure you select your team, and then initial scene set to window, immersive space renderer set to none, and then click next, and then save it wherever you want. And then click create. Great, so as usual, we get the boilerplate code, which essentially displays a simple sphere and a hello world text in a VStack. I'm going to get rid of all of that and just replace this with an empty view for now. So this will display nothing. Later, we'll come back here and design our actual view. Now, the first thing we're going to do is we're going to write code to detect the image. So essentially we got a book. Inside a book we got a certain page with a certain picture of Steve Jobs there. And what we want is we want the Vision Pro to detect when that image has appeared and then place what you call an anchor there. So fundamentally how image tracking works is under the hood, ARKit would use fancy computer vision algorithms to detect that image in the scene. And when it detects an image, it would provide you with an anchor, an image anchor, which is essentially a lock onto that image, right? A lock which stays on that image regardless of where the user is. So that lock or the anchor placed on the image is what we'll use to essentially place our own digital content and overlay it there. That's how you build augmented reality experiences. So in this case, what we need is an image anchor. An image anchor is the anchor that essentially anchors images. So for that, I'm going to create a new class. And I'm going to name this, say, image detector. Now for this class, I'm going to import ARKit, because remember ARKit is the framework that does all this fancy computer vision algorithms. So in this image detector class, it will have a dependency on first an ARKit session, and then it will also have a dependency on what you call an image tracking provider. So what you essentially do is you create a new ARKit session, and then you provide the ARKit session with a specific kind of provider, in this case an image tracking provider, which will then allow ARKit session to provide you with image anchors specifically. So this image detector class, it will have a constructor as usual. This is just autocomplete with GitHub Copilot, and the constructor essentially initializes these two objects, right? ARKit session and the image tracking provider with whatever we provide when we create this class. So this is just the constructor which initializes these objects. And then the image detector class will first have a function called start session, which essentially starts the tracking session. And then it will also have a process updates function. So process updates. And this process update function, what it will do is it will give us the image anchors whenever ARKit detects one. And it will provide us with that here. And then we'll just layer that up to the content view using a closure or a callback or whatever. So that's how we're going to design this. So first, to initialize and start the session, what we do is we take the ARKit session. So this guy here, so session, and you can see there's a run function, right? This runs a session with the data providers you supply. So there are different kinds of data providers in visionOS. You got the image tracking provider, you got providers for hand tracking, and you got providers for different kinds of tracking essentially. In our case, we're trying to detect an image in the scene, right? So we need an image tracking provider, which is exactly what we have here. So I'm going to do session.run, and then for the provider, I'm going to provide it with the image tracking provider that we have here. So the image tracking provider. Great, simple as that. Now we'll get a few errors because firstly, this is an async call. So we need to mark this with await. And when we do that, we need to put this in an asynchronous context. So this function becomes async. That should take care of that error. Now we also say call can throw, but it's our mark with try. So this call can throw an error. So what we're going to do is copy that, wrap that inside a do catch statement. So we're going to say do something. And if there's an error, catch it. And for catching it, we're just simply going to do a fatal error for now. Again, don't do this in production. This is just for prototyping purposes, right? So fail to start AR session with whatever error you get. And I'm going to paste that code here again, the one we had before, inside the do statement. I'm going to prefix that with a try. Great, so that's the start section function done. Essentially, we simply run the session with the image tracking provider. This would essentially get the engine going, and ARKit would essentially start tracking images. And if you ask which images, it will be the reference images that you would provide to the image tracking provider when we create this class. We'll come to that soon, don't worry. So what we want is, after we call the start function, ARKit's essentially detecting the reference images in the scene, and then it would create image anchors for that. And what we want to do in this process update function is essentially retrieve that image anchor and send it to the content view, so that content view could use that to display our own digital content on the image anchor. Awesome. So here, what we want fundamentally is to retrieve the image anchor and layer it up to the content view. Great, so let's do that next. It's quite simple. What we can do is, we got the image tracking provider, and here you can see there's this anchor updates guy here, right? This is an anchor update sequence, a sequence of updates that provide information about images a provider provides. What we can do is literally loop through these updates by doing, say, for await update in image tracking provider.anchor updates. So for each of the update, we can run specific code here. Async in a function that does not support concurrency. So we need to make this function into an async function as well to fix that. Great. In this, for each update provided by the image tracking provider, if you do dot, you can see it provides us with an anchor. This is the image anchor. This is the information that we need to place our digital content. So if you do the anchor and then you do dot again, let's see what information we get with the anchor. We get the estimated scale factor. We don't need that. We get the isTracked property. This is a boolean that indicates whether ARKit is currently tracking this image. We'll use this later when we design our content view, because we need to know when the image is tracked and when it's out of view, right? Based on that, we'll show and hide the video. Great, so we need that, and we also need this guy here. This is essentially the world space position of the image anchor. And we need this because where the image anchor or the lock is placed, that's where we'll place the video, right? So we need this transform information here. But essentially, this anchor contains all this information that we need. So what we can do is simply pass in this anchor to the content view whenever we receive one. So every time we got this new anchor update, we'll layer that up to the content view. To layer it up, we'll use a closure. So this function, let's provide it with a closure. So let's call this on anchor update. And this closure is used to layer in an image anchor. It would take us input the image anchor and then return void. And let's prefix that with escaping. Great. So now inside this for loop, every time we get a new update, what we can do is let image anchor equals update dot anchor, and then we will call on anchor update and then pass the image anchor here. So this is how we layer this information up. Great. So all this function does is it loops through the updates that image tracking provider provides. Whenever it gets a new update on the anchor, this guy would loop through all of that. And then whenever we get a new update, we take in the image anchor from the update, and then we pass it on to the closure here. And this closure, we'll use it to layer up the information to the content view. If that confused you, don't worry, it will make sense as we start using this class, right? All you gotta remember is this class is used to first get the engine running for the image detection, and second, to get the image anchor information out of the image tracking provider whenever there's an update. And this image anchor is what we'll use to place our digital content on the image. Great, so let's use this class now. So I'm gonna go back to the content view. So first I'm gonna get rid of this preview just so that you can see things clearer, because we don't really need the preview. And I'm gonna get rid of the preview code as well. So first, let's create the image detector, the class that we just created. And for the image detector, to construct this object, we need to provide a ARKit session and an image tracking provider. For this, we need to import ARKit in this class. Let's import ARKit. And for the ARKit session, you construct a new session. For the image tracking provider, let's create an image tracking provider. And now you can see when you create an image tracking provider, you need to provide reference images, right? Essentially, anytime ARKit detects that image in the real world, it will provide you with an image anchor for it. So here's where you specify which images you want to track. Here I've got an image in JPG format of Steve Jobs. I got this from Wikimedia. Depending on what images you're tracking, you need a JPG version of it. Once you've downloaded that to someplace in your desktop, what we can do is go here to Xcode project, go to assets, click add and go to AR and textures, create a new AR resource group. I'm going to name this book images. Again, name it whatever you want. And inside here, you can see that you can drag and drop AR reference images or object files. Object files is what you do for object tracking, and image files for image tracking. So in this case, I'm going to simply drag in the Steve Jobs picture. I got a warning here, and if I hover over that, you can see it's AR reference image must have non-zero positive width. If you go to the inspector tab here, you can see here there's a option for the size of the image, the width and the height. This is essentially the real world height and width of the image. So if it's in a book, just measure the height and the width of the image in the book. In my case, it's essentially 5 centimeters. Again, you can play around with these values, just make sure it's accurate enough. And then you click enter, it would give you the height. So width of 5 centimeters, height of 6.4 centimeters. Awesome, so that's the reference image. So now going back to the content view, here when we're creating the image tracking provider for the reference image, what we can do is say reference image dot load reference images and in group named. So the group is essentially this book images group here, right? So I'm going to copy that name and paste that here. So what this would essentially do is it would load all the images inside this book images group. So in this case, inside the book images group, there's just one image, Steve Jobs pic. So it will just simply load that and provide it to the provider. So here we create an image detector, which would essentially detect these images that we provide here, the reference images, and give us anchor updates whenever we receive new images. And those anchor updates is what we'll use to display our 3D content. In our case, we'll display a video player onto that image. So let's do that next. So what I'm going to do is here in this empty view, I'm going to add a new asynchronous task. This essentially runs some asynchronous code by using this modifier. And here, first, we're going to start the image detector session, right? So we're going to do image detector start session. You can see this is an async call, and that's why we put this call inside a task. This would essentially start the ARKit session configured for tracking this reference image. And once we start it, we also want to add another asynchronous task. And this time, this should be await image detector dot process updates. So this would process the updates from the session for image tracking. This is the function that we just created earlier. So this gives us an image anchor. Whenever ARKit detects some updates to the image anchor, what I'm going to do is store this inside a variable. So I'm going to create a new state variable, and this is image anchor. Let's make that an optional. And now here in the process updates function, every time we receive a new image anchor update, I'm going to store that in that state variable. So self image anchor equals image anchor. Awesome. So we start the session, and here we process updates from the image detection session, where we get all the useful information we need from image anchor. And the useful information is essentially two things. One, whether the image is currently being tracked or not, which we use to hide or make visible the video player. And two, the world space position of the image anchor, where the lock is in the real world. And we'll use that position information to essentially position our own digital content, the video player, at that same place. That way, the video player will stay locked to that image that we want to detect. Also, we need to do one more thing, and that is we need to go to this guy here, our project file, go to the info plist. Over here, we need to add a new key, and you need to call this NS World Sensing Usage Description. Make sure it's spelled exactly correct. So this is essentially how you ask permission from the user to track their surroundings, right? Any kind of ARKit session where we want to track images, we need to provide this in the info plist, because this way the system will request the permission from the user to sense their world. So just make sure you copy paste the exact key name, and you can just type in any message you want. I'm just going to say, we need to track your surroundings for image detection. This is the string that will essentially appear in that system alert that visionOS would trigger when the app's first installed. Awesome. So that's just sorting out the permissions that we need from the user. So that's done. Let's go back to our content view. And now we got all the image detection bits ready. So essentially, we start the session and we process the updates. And every time we get a new image anchor, we store that in the state variable, right? So now what we want to do is every time this guy gets set, it would either mean ARKit has detected an image anchor and it has stored there, or it has been updated. So whenever the image anchor is set or updated, what we want to do is essentially place a video player on that anchor position and lock it there. So that's the first thing we want to do. We want to place our video player onto that lock so that it would stay anchored. So for that, we need to get rid of this empty view. Instead of that, we want to create a reality view. So I'm going to replace that with a reality view with both a make and an update closure. The make closure is an asynchronous bit of code that is essentially what gets run when the reality view is first displayed. And then the update closure is what gets run every time you need to update the scene, right? So this is essentially the initializing of the scene. And this is what you use when you want to update the scene. You add all the logic in here. There's this content guy here, which contains a list of all the entities in your scene. Everything in your scene is an entity, whether visible or invisible. So for example, in our case, the video player would be an entity, and that would be an entity that we would add to this content guy here. And the moment you add it to the content guy, it will appear in the scene. We're going to ignore the make closure for now, because we don't need to do really anything when the view first appears. What we want to do is only when an image anchor is set, i.e. when the image detector has detected an anchor. For example, when the user turns the pages and the image is detected, the moment it's detected, this image anchor would be set and there will be a value for this, right? So when that happens, what we want to do is we want to update the scene by creating a video player at the position of this image anchor. So let's do that first. So here, number one, what we want to do is add video player to the image anchor's position. So I'm going to say here, add update, because this could also be an update to the position. So for this, we first of all need a video player, right? Like we need that plane that plays the video of Steve Jobs. So the way we're going to create that video player is we'll first create a model entity. So model entity is any kind of entity in visionOS with mesh and a material. So all 3D models would be a model entity. So we're going to create a model entity for a plane, like a rectangular plane. And then for the material of that plane, we'll use what you call a video material. It's a special kind of material that lets you play videos. So every model has some mesh and a material, right? The mesh gives it the geometry and the material gives it the color of the visuals. And in our case, instead of giving it a static color, we'll give it a video material, which lets you play a video on the material. That's how we'll create the video player. So for that, I'm going to create a new data structure. I'm going to call this video plane. This is the plane that will essentially play the video. And this would first have an entity. This would be the model entity, which contains the mesh and a material, including the video material. And then it will also have a video player. So this video player is of type AV player. And this guy is essentially what you use to initialize the video material passed to the model entity. And we need a reference to that because we need to essentially programmatically play or pause the video, right? For example, when the image first appears, we want to play the video. And when the image disappears from the scene, we want to stop the video. So we will do all those playback controls using this video player. And it says cannot find AV player in scope because we need to import the framework for that, which is import AV foundation. This is the framework that contains that module. Great. So this video plane guy here would contain the entity and the player itself. So I'm going to rename this from video player to player because it's already implied that it's a video player by the data structure name. Great. We're also going to add a static func, which we can use to essentially construct this video plane, right? So I'm going to create a make function, and this should return a video plane. So first we need to have the mesh, and then we need to have the video material, and then we'll create a model entity with the mesh and the video material. So for the mesh, I'm going to use a plane. To create a plane mesh, I'm going to do mesh resource dot generate plane with a width and a depth. And the width, I'm going to make it 0.06, and the depth, I'm going to make it 0.075. And again, these values you can change depending on the size of the area. For example, if you're tracking a bigger image, you want a bigger plane to essentially place on that image to cover the whole image. Again, this all depends on what the size of the image that you're tracking. But in my case, this is the value that worked, and that's what I'm adding here. So this is the mesh, and then we need a video material, right? To create a video material, you can do video material equals video material with the AV player, right? So first we need to create an AV player. And this AV player is what we'll use here as well, because that's what controls the playback for the video that's passed to this video material. So let's create the AV player first. Let player equals AV player. And here you can see you can create an AV player with a specific URL that's pointing to a video in our case. So for that, we need a URL. So I'm going to create here, say video URL equals bundle.main.url and for resource video with extension MP4. Again, here, what we're doing is we're loading in a video file from our bundle, right? And we're force unwrapping here because we'll make sure that the video is in our bundle. So it's safe to do it. Great. So here for the video URL, we want to point it to an actual video, right? So for that, what you can do is just literally download any video that you want, say in MP4 format, and then just import it to the project here. So what I'm going to do is go over here inside my project folder. I'm going to say add files to the project. And here I'm going to go to my downloads directory and I've got a Steve Jobs video here, which is in MP4 format. And I'm simply going to add that to the project. And make sure you select your project target here. That's selected and then click finish. So now if it's successfully imported, when you click on the video, it should play back in your Xcode editor, right? Awesome. So that's the video imported. And now we can simply, over here where we're creating the URL that's pointing to that video, we can simply replace the resource name with Steve Jobs. So this is the exact name of the video file that you imported. And then the extension MP4 because that's an MP4 file. Great, so this video URL points to that video that I just imported of Steve Jobs. And now we're going to initialize this AV player with that URL, which points to that video. So here, all we're doing is we're creating the video material. And we do that by creating a URL that points to the video that you want to play. And then we create a video material using that AV player. And this material would essentially play the video. Obviously, you can control the playback of the video in this video material using this player guy here, right? This instance. And that's what we'll set this guy with, so that wherever this data is constructed, we have access to that player and we could control the playback whenever we need. Great, so now we got both the mesh and the video material initialized with the Steve Jobs video. Now let's create a model entity out of the mesh and the material. So here I'm going to do plain entity equals model entity. The mesh, I'm going to pass in the plain mesh, again this guy here, and the material, we just have one material, which is the video material, which contains the video. Awesome. So now we got the plain entity, which is the model entity that contains that plane that plays the video using the video material. Now what we can do is finally, I'm going to return that instance now. So we're going to return a video plane with an entity, and the entity would be the plain entity, this guy here, which contains the video material. And the player would be this player that we initialize the video material with. And this would allow us to essentially control the playback of the video inside this video plane. Awesome. So this function essentially creates a video plane with a video plane entity, which contains the video material, and the video player, which allows us to control the playback of the video inside this entity. Awesome. So that's a video plane data structure, which essentially contains all the data we need for the video plane that we want to display in the scene, and as well the video playback controller, which is done using the player. Awesome. So now what we can do is simply go back to the content view, add a new state variable. I'm going to call this, say, video plane. And here we're going to create a new instance of the video plane, right? So video plane.make. Again, make is the function that we just created, which essentially creates an instance of a video plane with both the model entity and the player that we need. Great. So now we got the image anchor, which is a state variable that gets updated or created whenever ARKit detects the image that we want to track. And then we also got the video plane, which is essentially that plane with the video player that will play the video, right? So we're going to use both of that now to essentially display the video player in the real world. Whenever the user looks at the image in the book, we want to overlay that video player over that image. So for that, again, Reality View is how we display 3D content in visionOS. And inside here in the update closure is where we make updates to the scene, right? First, whenever there is an image anchor set or updated, place video plane at the anchor position. So that's how you overlay the 3D model that we want over an anchor, right? This is how you create augmented reality experiences. Awesome. So that's the first step, place video plane at the anchor position. And then after that, what we'll do is we'll enable or disable the video playback depending on whether the image is currently being tracked or not. For example, if the user turns the page, the image is out of view, so we want to disable the video, right? And when the image comes again, we want to enable the video. We will essentially use the video player inside this model to control the playback. Great, so let's do these now. First, to place the video plane at the anchor position, I'm going to first check if the image anchor is set, because that's optional. If it's set, great. If it's not, we just want to exit and do nothing. And then remember, the video plane model has an entity and a player, right? The entity is the 3D model itself. So we want to set the position of that entity to match the position of the image anchor. Dot set transform matrix. For the transform, we're going to use the transform of the image anchor, right? So that's going to be image anchor and origin from anchor transform. So the origin from anchor transform is the transform of the image anchor relative to the world. Great, so that's the position of the image anchor. And we're going to make that relative to essentially the world space, I believe. Great, so that sets the position of the video plane, the entity position, to match the anchor position. So at this point, the video would be overlaid on the anchor. And now we need to do one more thing. We've not added to the scene yet. So to add to the scene, we're going to do content that contains a list of all the entities in the scene. Add, and then the entity is the video plane dot entity. Again, that's the model entity for the video player. Great. So this is how you place the video plane at the anchor position. So that's number one. And number two, we need to enable or disable the video playback based on whether the image is being currently tracked or not. So to enable or disable the video, we could use the player component inside the video plane model. If you go to the struct, we got the model entity, which is the 3D model itself, and the player, which controls the playback. So this AV player, this player guy, is what we're going to use to play or pause the video based on whether the image is tracked or not. Now, how would we know when the image is tracked or not? How would we get that information? Again, that information can be obtained from the image anchor dot is tracked. You can see this is a Boolean value that indicates whether ARKit is currently tracking this image. So that's exactly what we need, right? So we could use the status of that to play or pause the video. So we're going to do if the image is tracking, if the image is in view, then we're going to do video plane, again, this guy here, and use the player inside. And then the player has a play and a pause function, right? Play begins the playback of the current item and pause pauses the video. So we're going to play to play. And then if the image is not tracked, we're going to do video plane dot player. And this time we're going to pause the video. Great. So that's the playback control. We also want to do one more thing. We also want to hide the model itself based on the tracked status, right? So the entity has a property called isEnabled. This essentially lets you enable or disable the entity. I'm going to do isEnabled. I'm going to control that value based on whether the image anchor is tracked or not. So if it's tracked, this will be true, i.e. the video entity would show. If it's false, this would be false, i.e. the video entity would hide. This two guys here essentially controls whether the video is shown or not based on the image tracking status. Great, so that's how it all hooks up. We got the image anchor, essentially contains information about the lock for the image that ARKit has detected for us. And whenever that gets set or updated, this guy gets called and we update the position and the playback status of the video. Awesome, so that's it. Now, before we run this, we need to do one more thing. If you go to the entry point of the app, the starting point of the app, which is named after your project name. So in my case, this guy here, and it's also marked with this main guy here. So here you can see we got a window showing the content view, right? But that won't work because for ARKit based experiences, we always need to display the app, not in a window, but in a immersive space, and more specifically, a mixed immersive space. So instead of displaying in a window, I'm going to get rid of that and I'm going to do immersive space. And the content I want to display is the content view that we had earlier. And the type of the immersive space, I need a mixed immersion style, right? So I'm going to do immersion style. And for the selection, I'm going to create a new state variable so I can bind it to the immersion style modifier. I'm going to do state var immersion style, and the immersion style would be not immersive, but mixed. So the mixed immersive space is essentially how you block all other apps, and at the same time, you'll get video passed through the Vision Pro so that ARKit can detect the surroundings of the real world. So that's the mixed immersive space. So now I'm gonna bond this immersion style to the selection guy here by doing $immersion style, and the options here, I'm gonna do mixed, progressive, and full. Awesome. Before we build and run, we need to do one more thing. Because we're showing the content view inside an immersive space now, and not a window like before, we need to set one more permission in the info plist. So if I click here, info plist, here before we added a world sensing usage description. This is for asking permission to track the user's world. Now, in addition to that, we're going to go to the application scene manifest, and here you can see preferred default scene session role, set to window. This is telling visionOS, hey, when the app first starts, we're expecting a window to be shown first. But now that's not the case anymore. Now we're showing an immersive space, right? So this is going to be set to immersive space application session rule. Great, so now visionOS knows that when the app first starts, it's expecting an immersive space, just like we have here. Awesome, so now let's try building this app and see what we get. Right, so now when the app first starts, you see the system prompt asking for permission to track user surroundings. This is the world sensing usage description that we added in the info plist. And you can see the message that we specified there as the value appears in the system prompt, right? We need to track your surrounding for image detection. Awesome, so I'm going to allow permission for this. And now ARKit is behind the scenes, is on the lookout for the reference image that we provided, which is inside this book in one of the pages. And the moment it sees that, it will detect that and place an anchor there, and overlaid on that would be the video player. So let's see if that's working. So I'm going to flip through the pages, again, read through the book, and
is Steve Jobs, February 24th, 1955.
the moment you
Birthday.
arrived at the reference
Steve
image, you
Jobs
can
is
see
born to
the
Joanne
video
Carol
overlay.
Scheib.
So ARKit has detected the reference image and it has overlaid the video player on top. And obviously you can see the image tracking is a bit flaky. It doesn't track very smoothly in real time. That's because the frame rate is really low, but in the future versions of visionOS, that would improve. Great, so now if I flip through a different page, you can see the image is out of view and ARKit is not tracking it anymore, and we're hiding the video player correctly. And when I go back, again, it's visible again. Basically, ARKit looks for this reference image, and the moment it detects that, we place our own 3D content, in this case, a plain mesh with the video material. The video material is the bit that's playing the Steve Jobs video. Great, so that's it, and I'll see you soon.